Okay, now that we have the arithmetic and general tabs under our belt, let's tackle the time functions and hydrologic tabs, both of which have a lot of good functionality on them. So let's start here with the time functions tab. And one of the things we have here is operations for intervals. And if you remember, the interval is the like the 1 hour or 1 day of the DSS time series path name. So it's the E part of the path name. That is for standard intervals. A standard interval is an interval that can be used in a DSS path name. So 1 hour, 6 hour, 1 day, these types of things. There are custom intervals that can be used, and so you might want to analyze something in an interval of 7 hours. I don't know why you would, but it could come up. And so those would be custom intervals. They are standard repeating intervals that each interval from one time to the next to the next to the next is always the same interval, but they're not standard intervals within HEC-DSS. And then we have pattern intervals, and those are really irregular. There's no standard set amount of time from one value to the other. That's what we call an irregular time series. And so pattern intervals are provided, if you need to use a pattern interval, by providing the pattern time series. So you provide a time series that has times that you are concerned with. Okay. With those definitions out of the way, let's talk about operations for intervals. We can do period analyses of standard, custom, or pattern intervals. So we can do general statistics. So we can count how many values fall in one of these intervals. We can, give the arithmetic mean, or we can get the min or max of those. We can do accumulation over an interval, and we can do an integration over an interval. Now, integration is really just the accumulation times the time between the values. It's the area under a curve. You've taken calculus. You're familiar with what integration is. And so it's accumulation, but not just the accumulation of values. It's taking into account the amount of time between the values as well. So those are things that we can do here. We can also do some resampling. We can go from one regular interval to another regular interval. We can go from an irregular time series to a regular interval time series. And we can do that by a couple of different methods. We can interpolate the values of the irregular time series at the regular interval times we want. Or we can use what's called snapping. And snapping differs from interpolation. Instead of calculating via linear interpolation what the value at that time would be given the source time series, you simply take the value at the closest value to that time and just move it to that time as if it happened then. Sometimes snapping is okay. Wouldn't use it a lot, but you'll use it you will actually use it in the workshop. I believe we have to snap to an interval in there. Another thing we can do on the time functions tab is we can extract subsets of data. So we can say, give me all of the data out of this period of record. I want all the January data, or I want all of the data that happened on Mondays. So we can do stuff like that via the time functions operators here. We can also change the time series type. We can go from regular to irregular and vice versa, like I mentioned. We can also go to pseudo-regular. Pseudo-regular is in HEC-DSS is actually irregular, but it's named like a regular time series. And it's intended for data that is predominantly regular time series, but might not be actually exactly regular. So it has a specific naming style. So instead of an interval or an e-part type of 1 hour, it would be tilde 1 hour. And instead of, like 1 week or 1 month, it would be tilde, that same thing. So it's truly irregular in nature. The values can be at any time, but it's really to indicate that this time series is, for the most part, regular, but it might not actually be. So we can go from irregular to, regular to irregular, and back and forth between irregular and pseudo-regular. The last thing on the time functions tab, the last category of stuff, is time shifting. So we can move or copy in time. So if we have a data set and it's in January of 2012, and we say, well, what would that look like if it happened in June? What would that look like if it happened in 2020? Those types of things. So we can move in time or we can copy in time. And the time functions tab provides operators for that. So standard and custom intervals, I mentioned the intervals when we first started this slide. The min, max, average, over period operator, that's the first one. It's the one that happens to be highlighted in the picture here. The standard and custom intervals can be accessed from there. The pattern intervals, we'll see those also on the Hydrologic tab. Really, I think those operators should have been over in the time functions tab, but hey, that's the way it is. And also the min, max, average, over period. Interpolate at end of period, because when you do min, max, over period, there's several different operators you can have, or different choices you can have within that operator, is the way I should say that. If you choose the interpolated end of period, that's the same thing as changing the time interval if you're using a standard interval. So some of these things can be done. There's a lot of functionality here. It can get a little confusing, and some of it can be done more than one way to achieve the same result. But you have a pretty vast array of capability of manipulating the times and analyzing the standard intervals, custom intervals, or pattern intervals within this. So let's move on to the Hydrologic tab. And we have a lot of operators under this tab, and let's get with them. One of the categories, the main categories in here, is ratings. So you can have only one independent variable and one dependent variable in one of these ratings. So it can be forward or reverse. There's also a way, and this is by a special use of the way the paired data record is structured, you can use labels, the labeling capability for different curves. If you have numbers for the label instead of words or text, you can use that as a 2 independent variable rating. And so you could have something like, say, elevation, reservoir elevation, and gate opening as your 2 independent variables, and gate discharge as the dependent variable. You can also perform Conic rating, Conic interpolation rating, and that is when you for use to convert elevation to either storage or area, and that's where you don't have a real detailed survey, but you just have, say, areas at different elevations. You can use Conic interpolation to generate storages or areas between the elevations at which you have the areas at. I don't know that this is used much anymore. That was a method that was used back in the Dark Ages when I roamed the Earth using HEC-1. That was one of the methods used in there. So anyway, that's the rating portion of the Hydrologic tab. Now we can get to interpolation using a time pattern, and these are the operators that I said should, I believe, or that they fit. The way I should say that is I believe they fit better in the time functions tab than they do in the hydrologic tab. But here we are, and so you can linearly interpolate between values, and that's called a shift adjustment, and that is doing interpolation with a pattern, with an irregular, it can be irregular, it can be a regular time series, but it can also be an irregular time series, and so you can just interpolate between the times at that time series for the values at the current time series. You can also do the same thing, except instead of interpolating, you can just set it the values to whatever was most recent in that time series. And so that's what period constants are. And then here you have shift adjustments and period constants. They're both interpolation using a time pattern, but they have different ways of doing it. And some of this stuff gets a little esoteric to describe. If you get the actual slides for this, I know you can't do it on the video, but if you get the actual slides for this presentation, you'll notice that on several of the slides I have this thing up there that says link. And if you click on that, you actually get, hopefully, there we go, you actually get the link of the user's manual that talks about these areas. So utilize that, because we don't have time to describe everything in enough detail in a lecture format like this. Okay, so let's go on to the next topic in the Hydrologic tab, and that's regression. So you can perform multiple linear regression. You can either compute the regression constants, or you can apply previously computed regression constants. You can also do polynomial applications. Now, you can't compute the polynomial here. You can only apply it. But if you have a polynomial that has been computed, you can apply it with or without an integral. Again, if you need information on what this is and why you would use it, I suggest you go back to the HEC-DSSVue manual, as I showed in the link, and read up on it there, because it gets a little too deep to discuss here very much. But you can do regression analysis. I will say this, that you can do multiple linear regression analysis here. If you need single regression analysis, single linear regression analysis, you can get to that over on the statistics tab, which we'll talk about last. So you can do that, but if you're on this tab, you can get multiple linear regression, and over on the statistics tab, you can get to the single linear regression. Okay, the last thing in the hydrologic tab that we're going to talk about is routing. Excuse me, the next to the last is routing. So hydrologic tab allows you to perform Muskingum routing, Stratosliger routing, or modified poles routing. And you can have your time series, and you can have the constants for these various methods specified, and it will route your time series and give you a resulting time series for that. So I misspoke when I said the last, because there's one other category, and I'm just calling that other, and I truly believe it's stuff that maybe no one uses anymore. But historically, it's been in the HEC toolset for years and decades, and so it is still provided here if there's any need for it. I don't know if there's any flow accumulator gauges in existence. It could be that there are. If there are, we provide a way to take the data and utilize it. And also decaying basin wetness. I think we probably have within our hydrologic tools way better methods of doing stuff than that. But if it's there and you have been using it and you need it, it's there. If you don't know if you need it or not, I'm going to guess you probably don't. Anyway, rating, interpolation using time pattern regression, routing, and other are the things that we get out of the hydrologic tab. And so combined with the time functions tab, that's quite a tool set, even in just those two tabs alone. And so that wraps up this session, and we'll come back for the last session next and talk about the smoothing and statistics tabs.